Anytime we're working with blobs, it's highly important that we're running in a scale environment and that the data must be in a shared location. The load balancer in itself is not sticky, meaning that all requests coming in through the load balancer do not use the same session consistently to the same backend web role or worker role. Blobs in Azure can be up to 1 terabyte in size, and you can have as many containers as blobs as you want. So for each Azure storage account can have many containers, and each container can have as many blobs as you'd like. And containers can be created and destroyed on the fly. Blob addresses follow the same pattern as tables and queues. One account can have multiple containers, each container can have multiple blobs, but the difference between blobs versus tables and queues is that blobs can also be used to create blob pages and blob blocks. However, the style is the same. You have an account, you have the container, and then you have the blob name. Containers have an interesting characteristic in that they behave similar to a Windows directory structure. Containers are similar to a top-level folder, and since you're dealing with containers, one container can contain other containers. So it actually mimics, in some ways, a Windows Azure directory structure. A single container can hold up to 100 terabytes of files, but it can only contain blobs. Another one of the differences between blobs versus tables and queues is that each container has an access security level. The first is private, and this is the default access level, which will require that you specify the account and account key to access any container and blob. You also have full public read, and this provides anonymous access, which is the ability to list contents of a container and access to container data. But you also have public read-only. This is also anonymous access. It only allows you to list blobs, not the contents of a container, so no access to container data. Talking a little more about blob containers, again, you can have multiple containers per account, and each container has a special root container. Talking about blob containers, a blob container holds a set of blobs, and you can set the access policies at the container level. You can also associate metadata with a container, and up to 8 kilobytes of named value pairs per container. When working with containers, you can actually list the blobs within a container, including the blob metadata. However, you cannot search or query against the metadata of a container or blob. For example, you cannot select metadata where metadata value equals some value. From a throughput and partitioning standpoint, blobs are effectively in partitions of 1, meaning one blob equals one partition. And the target is 60 megabytes per blob for optimum performance. So let's take a look at how you would work with containers. And it's actually very similar to working with tables and queues. The first thing to do is to get an instance of your cloud storage account, then get an instance of the cloud blob client, and then you can get an instance of a specific cloud blob container. Once you have access to the cloud blob client and cloud blob container, you can list containers, create containers, or delete containers. And once you're within a container, then you can start working with blobs. And it's the same way as working with containers. Get access to your cloud storage account, to the cloud blob client, to the specific container, and then once you have access to a container, you can enumerate the blobs within a container. The question is, how do you upload and download a blob from Azure Storage to Azure Storage? Well, it's actually quite easy. You have 4 options. You can use the upload file method, you can specify the upload text method, or you can specify the upload from stream method. The last method is upload byte array method. Downloading the blob is essentially the same thing. The options are download text, download byte array, download to file, and download to stream using the memory stream. We talked about adding metadata to containers and blobs, and essentially all metadata is stored in a simple dictionary in Windows Azure. Anytime you add metadata to a container and blob, you must call the setMetadata method to persist that metadata to the store. So here's a quick example. In this example, I'm setting a customer ID metadata tag to a container. So there's the key value pair there. And then I'm also doing that on the blob, setting a key value pair of author and a name to the blob metadata. Then when I'm all done, I must call setMetadata to persist that information to the store. Blobs have a concept of a blob snapshot. So let's talk about snapshotting. When you snapshot a blob, it pins a version of your blob that is read-only, and it's as simple as saying blob.createSnapshot once you have an instance of the blob that you want to work with. If you want to start working with that blob, you just get a reference to that blob by specifying the snapshot date and time. Now realistically, Windows Azure works with two types of blobs under the hood. You have a block blob, and this is really targeted at streaming workloads for uploading large blobs up into Windows Azure. Each blob consists of a sequence of block IDs, but the limit to a block blob is 200 gigabytes per blob, so nothing bigger than that. You also can set optimistic concurrency via the E-tags. The second type of blobs are the page blob, and these are targeted at random read-write type workloads. Each blob consists of an array of pages, with each page being identified by its offset from the start of the blob. Each page blob has a 1 terabyte size limit per blob. And again, you have optimistic or pessimistic locking concurrency via leases applied to that page blob. So let's take a look at uploading a blob using the block blob method. Here we have our blob storage in Windows Azure and the 10 gigabyte movie that we would like to upload to our blob. The blob name is the blob.wmv, and the way to do this is to basically break this blob up into chunks. Each block can be a maximum of 4 terabytes in size, but you can have as many blocks as you want. So in this case, we have block 1 through block N. So we start uploading that. We use the put block method to upload each block. So block 1, block 2, block 3 to block N. And once all the blocks are uploaded, I then call the put block list method to assemble all the blocks together in the right order. The great benefit of using the block blob method is that it is very efficient, and it's efficient in continuing and retrying, meaning if a block blob fails, it will continue to retry. And by breaking a blob into blocks, you can actually parallel out the upload of the blocks and upload in any order. And by calling the put block list method, Windows Azure will assemble those blob blocks in the right order. Let's take a look at a page blob for random rewrite. Here we have our 10 gigabyte address space. We can create our blob by specifying the size, and here we specified 10 gigabyte. And it's sparse storage, meaning we're only charged for pages with data stored in them. Page blobs are fixed page sizes of 512 bytes, and you can use random access operations, meaning I can say put blob and specify from 512 to 248. I can then put another range from 0 to 1024. I can then clear the page from 512 to 1536. And I can put another page from 2048 to 2560. This means I have random access operations. I'm not stuck to putting pages in a specific order. I can also return valid data ranges, meaning from 0 to 512 and 1536 to 2056. I can then also specify get blob from 1000 to 2048, which returns everything from 0 to the first 536 bytes, and then the next 512 bytes of the data stored in 1536 and 2048. Shared access signatures provide access rights to containers and blobs at a more granular level than by simply setting a container's permissions. I can grant users access to a specific blob or to any blob within a specified container for a specified period of time. I can specify what operations a user may perform on a blob that's accessible via a shared access signature. I can revoke the permissions at any time by using a short time period or reissuing the permissions, or I can just simply use container level policy that can be deleted. Here's a sample of applying a shared access policy. The first statement creates the policy which specifies read-only access for the first 10 minutes. The second statement lists all the blobs of the container and creates a list of URIs that have the shared access signature query string appended to them. I can grant access to a specific blob as well, and I could use the same code as above except with write permissions. Let's suppose that you have a nice set of images and movies from your latest vacation to Sri Lanka, and you want to make them easily available to friends and family around the world. The Windows Azure Content Delivery Network provides edge nodes around the world to make it easy to provide blob capability around the world. So for companies that need frequently accessed blobs, the Content Delivery Network is the solution. Blobs can be accessed from anywhere around the world, and data stored in the Content Delivery Network enables storage accounts to retrieve from the original storage container and cache those blobs at each edge node in a lazy load fashion. There are more than 20 global Content Delivery Network edge node locations around the world, in Europe, Asia, and the US. It is the same experience for all users no matter how far they are from the edge node where the storage account is hosted. From a cost perspective, for the US, the Content Delivery Network nodes is 15 cents per gigabyte plus 1 cent per 10,000 transactions. For the rest of the world, it's 20 cents per gigabyte and still 1 cent per 10,000 transactions. And any traffic going from a storage node to an edge node have the same standard rates apply. So how does Microsoft do this? Their goal is reach, scale, and capability. Over 3 terabits per second of capacity is available from over 20 global locations with a 99.9% availability. It's interesting to note that the Content Delivery Network hasn't just been made available for delivering blobs. Microsoft has been using the Content Delivery Network for a long time. In fact, when you get a Windows update, it's using the Content Delivery Network. So let's take a look at how the Content Delivery Network works. I have my public blob container and a single edge node in this example, and I have a video that I want to make available. And to make it available, here's the blob URL. Instead of having my users access the public blob URL, they're going to hit the edge node URL. And in this case, I have an orange hair guy that wants a copy of that blob. So instead of hitting the public blob container, he's going to access this blob through the edge node URL. So he makes a request for the blob. That blob does not exist at the edge node, so the edge node makes a request to the public blob container for that blob and downloads that blob from the public blob container and then sends that to the orange hair guy. The edge node can then at that point either delete the blob from the edge node or make it unavailable for a specific amount of time. But then we have another guy, the disco dude. This disco dude now wants the same blob, so he makes a request to the same edge node. And the first thing the edge node will do, it will call out to the public blob container and ask if the public blob container has an updated version of that blob. If it does, it will download the updated version to the edge node and send it out to the disco dude. Otherwise, it'll just recall the current version of the blob and send that to the disco dude. Windows Azure drives are a unique capability of Azure blobs. Windows Azure drives are a durable NTFS volume for Windows Azure instances, and essentially it uses existing NTFS APIs to access a network-attached durable drive. When working with Windows Azure drives, you can simply use the System.io classes from the .NET framework. The benefit from using Windows Azure drives is the ability to move existing apps using NTFS more easily into the cloud. They provide durability and survival of data on instance recycle, and a Windows Azure drive is essentially an NTFS virtual hard drive page blob. These page blobs can be mounted over the network as an NTFS drive, and they have local cache on instance for read operations. And on page blobs, all flushed and unbuffered writes to drives are made durable to the page blob. So from a capability standpoint, a Windows Azure drive is simply a page blob formatted as an NTFS single volume virtual hard drive. Each drive can be up to 1 terabyte in size. So page blob can be mounted on one instance at any time for a read-write, on the other hand, using read-only snapshots to multiple instances at once. An instance can dynamically mount up to 16 drives, and you have remote access via standard Blob UI capabilities. This means that you can't remotely mount a drive, but you can upload the virtual hard drive to a page blob using the blob interface and then mount that VHD as a drive. But you also have the ability to download that virtual hard drive to a local file and mount that virtual hard drive locally. A Windows Azure drive acts as a local drive mounted on the file system and is accessible to code running in a role. The data written to a Windows Azure drive is stored in a page blob defined within the Windows Azure Blob service and cached on the local file system. Because data written to the drive is stored in a page blob, the data is durable. Working with the cloud drive is done via the Cloud Drive Client library. And here's an example on how you would work with the Windows Azure Cloud Drive. The first line of code creates an instance of our cloud storage account. We then use the Cloud Drive class to initialize the local cache for drives that are mounted to this role instance. We then create the specific cloud drive and specify the size in megabytes. We then mount that drive as a network-attached drive on the local file system. We can then read and write to that drive. We can then snapshot that drive. If we need to, we can unmount that drive. One of the key concepts when working with blob drives is understanding the drives and their failover scenarios. All writes must be flushed to be persisted to the underlying page blob, and you can simply use the systemio.stream.flush command to do this. Read-write drives must maintain a lease, and they have a 1-minute lease expiration by default. All drives are maintained by the Windows Azure operating system driver, and you can unmount that drive on the rollEntryPoint.onStop method. For failure, the lease will time out after 1 minute, and then you can remount that drive on a new instance if necessary. From a best practices scenario, the key is to manage your connection strings and your account keys in the configuration file, not in code. Goes without saying that you really shouldn't share your keys. Make sure you wrap them in a service. Have a strategy for your accounts and containers. If you're letting just anybody create containers within your accounts, it could become a mess and unmanageable. So have a strategy for creating containers. And you might consider assigning a custom domain to your storage account. Now let's take a look at an example on how to easily work with blobs in Windows Azure Storage. In this example, we are going to create a simple application that shows how to work with containers and blobs. We will show how to create and enumerate containers as well as their corresponding blobs and provide a simple example on how to upload a blob. So to begin, let's fire up a new instance of Visual Studio and let's create a new project. And again, we're going to be using a Windows Forms application. So let's call this Windows Azure Blobs and click OK. Let's stretch this out. And again, we need to do several things on this. So we need to go into the properties of the project and change this from a 4.0 client profile to just a standard .NET Framework 4.0. And then we need to add several references. We need to add the references to the Windows Azure SDK. So right mouse click on the references, add reference. And again, we're going to browse to our C drive, to the program files, and then down to the Windows Azure SDK folder. 1.4 reference, and again we'll add the storage client, the service runtime, the diagnostics, and click OK. Great. Now we're ready to start slinging some code. So let's go back to our form, and we're going to work with containers first. So let's separate this by dragging a group on this form. And let's drag it up over here. And we'll just call this group containers for now. And within this, let's make this a little taller just to make sure we have enough space. But within this container, we're going to drop a few other, actually let's make this bigger for now so we can drop our controls into that container. We need one button. We're going to need more buttons than that, but let's drop the first button on there. We need a list box. We don't need to make that too big. We need a text box. We'll put that down here. And we need two more buttons. So let's scroll back up and we'll drag one more button and one more button. So we're going to put that here. We'll put that down here. Give ourselves a little more room, just so we know how we have enough room. Because this is going to be where we can enter the name of the container. We're going to use this button to list our containers. And let's make this a little bigger so we can see it. There we go. This will be command list containers. I'm going to make this list containers. This is going to be our delete container button if we want to delete the container. We'll change that name to command delete container. Spelled delete wrong. All right, here's our text box. We're going to name this text box text container name. And then this button is actually going to allow us to add the container. Add container. We're not out to win any user interface awards, so all right. Add container. All right, so now we're ready to work with containers. So let's go to the code behind the form, and we need to do several things. We first need to reference Windows Azure, and one more using Microsoft.WindowsAzure.Storage Client. All right. Up here, let's define a few things that we're going to, a few variables that we need to work with in this example. So the first one we're going to define is the actual container name, and then the blob name. All right. And like our other examples, we're going to define a region where we can store our account and key information. So add region. And then here we're going to define string count, string key. Now we need to go grab those again, so we know that this is appdevq. And let's go get our key again. Copy the clipboard, Paste. There we go. There's our region. All right, so the first thing we need to do is let's create a method that will list all of our containers. So we're going to say private void get containers. Now I could type a lot, but I'm going to save time and minimize this and go in and get some code here. So in my blob code, I'm going to go grab this code right here. We'll paste it in right here. Let's talk about what this is doing. Probably have an issue. Let's try that again. So the problem we had is we didn't have parentheses at the end of our method name. So simply by adding parentheses, our error went away. All right, so let's keep going. Let me explain what this code is doing. We need to add one more close bracket there, and then we're good to go. All right, so the first thing this is doing is we're clearing the list box. We're setting our cursor to a wait cursor. We're getting access to our account and keys. We're using those to get access to our storage credentials. Doing a reference to our cloud storage account. And then we're creating an instance of our cloud blob client. Once we have that, then we can start enumerating through and listing our containers through the list containers method. And then we're just looping through those and adding them to our list box. And we're putting a message box if we have an error. All right, so there's our get container method. But we have no containers. So let's keep going, because the next thing we need to do is let's go back to our form and let's actually call that method from our list containers button. So we're simply going to say here, get containers. All right, so now we can call that anytime. But let's go back and let's add the functionality to actually add a container. Now again, I could type a lot of code. Oh, forgot the bracket at the end. Now again, I could write a lot of code, but I'm going to go down here and grab this code from my add container method from the code I've already got. So let me grab that. And I'll paste that in here and I'll explain what's going on. All right, so we're in a try catch block, but the first thing I do is I look to see if the container name text field is actually empty or has a null or has an empty string. If it is null or empty or an empty string, I just want to throw up a message box saying that please enter a container name. Otherwise, if I did enter a container name, I want to create that container. So same thing, my storage credentials, an instance of the cloud storage account, an instance of the cloud blob client. Then I get a reference using the get container reference to the container that I specified in the text box. Now it hasn't really been created yet, so I can use on the container class the create if not exist method. Once I've done that, if it's already created, it won't do anything. If it hasn't been created, it'll actually create the container. Then I call the get containers method to show my containers in the list box, and then I just throw up a message box saying, hey, the container's been added. Okay? So let's compile this. Make sure there's no errors. 2 warnings, and that's all right because I've got some things that aren't really been used yet. I haven't used that, and I haven't used that. So let's run this and see how it works. So I'm going to list containers, and there's really nothing. I'm going to add a container, so I'm going to call this app dev test. I'm going to throw out a trick question. If I click the add container button, will it create the container? So I'm actually going to click add container. It says, nope, one of the request inputs is out of range. Why is that? That's because the container name, since the API is just a wrapper around REST, and all REST calls must be lowercase, all container and blob names must be lowercase. So if we just change this to all lowercase, it should work. Ta-da, container added. There it is. We're good to go. Okay, so there's our container. It's been added. And let's wrap this the container section up by putting the code in there to delete the container. Okay, so I'm going to do the same thing. I'm going to go in here and I'm going to find my delete container code. I'm going to paste that in there, and there it is, just doing the same thing. So again, cloud storage credentials, instance of the cloud storage client, cloud blob client, an instance of the container that I actually click on, and we actually need to add that code. Then I delete the containers and relist the containers. But before we demonstrate that, we actually need to go into the event of our list box and say at container equals list containers dot selected item dot toString. All right, there we go. So then now if we were to delete or select a container, this variable would contain that container name. Okay, so now we've just created our container. Now let's move over to the blob section. So we're going to actually go over here now and drop another group on here. I'm going to make this a little bigger actually, because the name of the blob can actually be pretty long. So we're actually going to make this pretty big. As big as we can get it. Okay, I got that. Now we need to drop a list box on there. We need to make this as big as we can because the container names need to show up in there. We'll do that. Okay, we're going to throw another button on there. We're actually going to call this delete blob. Whoop, spell that right. And then we're going to throw another text box on here and a couple more buttons. So for our text box, let's throw two more buttons on here. 1, 2. All right, we're trying to make it as pretty as we can, but we're still not professionals yet. All right, this button we're going to call browse, because with this button and text box, we're actually going to use it to browse to a file to upload. Let's say command browse, and this button will actually be called, oh, we need to change the name of this as well, of the text box. We're going to say, make this text blob name, and then this button will be called and add blob. Just call this add blob. All right, now we have everything in place to start working with blobs. However, let's just make this pretty and call this blobs. There. All right, let's save that. We're going to call it, oh, we got to make one more change. So this is going to be list blob. Okay, so let's work with our browse button first. So let's double click that, because what we want to do is we want to browse to a file. So let's go find our browse button. And here it is. Here's our browse code. Let's paste this in here. And all we're doing here is we're using the open file dialog class to open up the open file dialog to allow us to browse to some file that we want to upload. All right, and then once we pick a file, it's going to put that and display the name and path of that file in the text box. Okay. Go from there and let's add the code to actually upload the blob now. So again, that's a lot of typing. So I'm going to go down here and I'm going to grab this code. I'm going to add that right here. All right. So again, we're in a try-catch block. The first thing we do is we look to see, hey, have we actually selected a container to upload the blob to? If we haven't selected a container, there's no use of going on. Let's not do anything. We want to make sure that they have actually selected a container. Otherwise, change the wait cursor, our normal storage calls to the blob client, the blob container. But in this case, what we're doing is we're getting a reference to the cloud blob and a reference to the actual blob that we're specifying in the text box. We actually don't need that line of code, so let's delete that. And then we're simply, on the instance of the blob, we're simply calling upload file and passing it the name. We're also specifying a couple metadata. So there's the metadata. We're specifying a file name for it, and then the submitter, which is my name. And we're all good to go. All right. So let's go back. Let's compile this, make sure there aren't any errors. We're good to go. So let's run this now. Actually, before we run this, let's take this code. Let's actually open up a new notepad and paste it, because we're going to use this as our blob file. So let's save this, and we'll save it as, let's create a new directory in here. Call this temp. Call this my code and save that. So we're going to use, we're actually going to use this file to upload. We'll minimize that because we want to come back to that as well at some point. All right, we compiled, everything's looking good, so let's run this. So let's list containers. There's our container that's actually pulling from our Azure storage account. Let's browse to that file. So we're going to go to our temp directory and select that, and there it is. And so to simply upload it, let's click Add Blob. Blob uploaded. That was fast, wasn't it? All right, so how do we know that it actually uploaded? Well, let's close this, and let's add a little bit of more code to the click event, or to the event of the container list box. Okay, let's go look at the code there. And what we want to do is we actually want to add a little more code. Let's go back here, and let's go find our list container method. There it is. And let's add this code. All right, there we go. This code should start looking pretty familiar to you. So again, our cloud storage credential information, the account, the blob client. But in this case, what we're doing is we're saying we're creating an instance of the class of cloud blob directory, and actually getting the blob directory reference to that container. So it's actually saying, give me the directory reference to that specific container. Once I have that, because it's IEnumerable, I can now iterate through all the blobs in that container. All right? So we're good to go. Let's compile this to make sure there's no errors. There shouldn't be. Perfect. F5 to run. Let's list our containers. There it is. appdevq.blob.core.windows.net/appdevtest/mycode.txt. We have successfully uploaded a blob into our Windows Azure Storage blob container. All right, so the last thing let's do is let's add the code to delete the blob. This is fairly simple and just kind of a nice example. So let's go back and double click the delete blob code to view the click event of that button. And let's go find the delete. There's our add blob. There's our delete blob right there. We actually have to do one more thing as well before we can run this code. But let's add this code real quick, and then let's go. I'll come back and explain what that is. We actually have to go in here, and we actually have to say, when we collect this, say the following: at blob equals list blob dot selected item dot toString. That way, when we select everything, however, we're getting a couple errors because we named this different. So let's rename those to _blob. All right, no errors. Let's compile just to make sure. Excellent. So we should be able to delete that blob by clicking the button. So let's run this, list our containers. Let's select our blob and then click delete blob. Blob deleted. So now if we select this again, we may not be clearing the list box. So let's run this again just to make sure. Yep, no blobs. So what we didn't do is we didn't clear the list box. So let's scroll up to the click of the selected index change of the list container, and let's actually add this line of code. Right below this, we'll just add this line of code right there. That should do it. So when we click on a new container, it actually clears the list and then repopulates it. So we should be good to go. So in this example, we illustrated how to work with containers and blobs, how to create and enumerate containers and blobs, and how to upload a blob to a container.